Let's look at another projectile problem at an angle that's a little bit more complicated than the last one. Here we have from practice E, page 101, number 2, a golfer hits a ball at an angle of 25 degrees to the ground. If the golf ball covers a horizontal distance of 305 meters, what is the ball's maximum height? Again, let's draw a picture of what's going on here. We've got a golf ball that's being hit at 25 degrees to the horizontal. They don't tell us how fast, and it says that it covers this distance, and remember this is in the horizontal direction, so our x is equal to 301.5 meters. We have to think a little bit about what's happening here. If they want to know the ball's maximum height, think about what's going to happen as this ball flies through the air and comes back down this way. What will its velocity be in the y direction at its maximum height? Think about what happens when you throw a ball up in the air. When it reaches that maximum height, for just a split second, it's 0. So this is going to become an important part of this problem. Now, just like we've done in the other ones, we need to find the time that this thing is going to be in the air. All right, so we're going to begin with this particular formula from your formula chart that says that the velocity, the final velocity in the y direction, is equal to the initial velocity, that's in the y direction, plus the acceleration in the y direction, that's going to be g, times the change in the time. Okay? Now, I know that my final velocity is 0. And so now I can start moving components around in order to solve for time. Remember, we're trying to find the time here. So if I subtract VI from both sides, VI sine theta is equal to my G delta T. Then I can divide both sides by G. And so T is equal to VI sine theta. Now don't worry about that negative sign, because remember, our number for gravity is going to be negative 9.1 because it's going in the down direction. So really, the sign is going to remain positive. But we're going to leave it like that for now. Now, the problem you might be saying to yourself is, but wait a minute, I don't know the initial velocity. That's okay, because we can take this derived formula and insert it into another formula that will allow us to find that initial velocity, and then using the initial velocity, then we can solve the rest of the problem. All right, so let's look at something else that we know. We do know x. We do know the change in x. So let's go ahead and use that formula that says that the change in x is equal to VI cosine theta, okay, times the change in time. Okay, now I'm going to insert, instead of time, I'm going to put my new formula in there. VI cosine theta, and instead of t, and let's go ahead and just solve for this. Since we know those are going to be negative, we're going to make that positive just so we're not dealing with all these signs. It is going to end up working out. All right, and this is all divided by g, and this is equal to my x. Okay, so now let's kind of simplify this. If I multiply all this out, I'm going to have that x is equal to VI squared. See that? VI times VI. And then cosine theta times cosine theta, or times sine theta. all divided by g. So now we're going to take and rearrange that and solve for vi. Okay, so x, let's rewrite that over here. X is equal to vi squared cosine theta sine theta divided by g. Let's multiply both sides by g over 1. That's my reciprocal, so that can cancel. But now I've got gx equals vi squared cosine theta times sine theta. Okay, so I can divide by cosine theta, sine theta. But that makes it on this other side here. So cosine theta and sine times sine theta, can't squeeze it all in there. All right, so now let's rewrite this. Vi squared equals gx times sine theta times cosine theta. Oh, sorry, I've messed this up. It's divided by. Vi is equal to gx divided by cosine theta, sine theta. And then we're going to take the square root of that so that we get vi. Okay? Divided both sides by that. Sorry about that. So here's our formula that's going to allow us to find that initial velocity. All right, so go ahead and plug all those numbers in. Vi equals the square root of 9.81. We're just going to leave it positive because we changed those signs, times 301.5. Okay, all divided by the cosine of 25 times the sine of 25. And then when you plug all that in, you should get 87.9 meters per second for your initial velocity. So now that we have the initial velocity, now we can solve the problem for the maximum height. We're going to use a different formula, but we're going to use a formula that allows us to find delta y, which is our height in the vertical direction. So let's get rid of all this so that we can move on to the next part. So we've got 87.9. Right, so now let's take a look at the next part. Again, remember that the velocity in the y direction, the final velocity, is 0. We're going to use this formula that says our final velocity in the y direction squared is equal to the final velocity, the initial velocity in the y direction squared times sine of theta. That's going to give us that in that y direction, minus 2g delta y. Now all of that's going to be equal to 0. And again, we're going to use negative 9.81 meters per second squared for g. All right. So all that's equal to 0. We have to rearrange this in order to find delta y. So let's start out by moving the 2g delta y to one side. sine, we're going to add 2g delta y to both sides. Now that's equal to 0 there. So that's going to give us positive 2g delta y. Now I'm trying to solve for that delta y, so I'm going to divide both sides by 2g. Okay, and now I have a formula that will allow me to find the maximum height, which is delta y. Delta y is equal to my initial velocity, which we found before was 87.9 squared. Oops, I left a square off. Squared times the sine of theta squared, and the theta here is 25. 25 squared, all divided by 2 times 9.81. And that's negative 9.81. So all that's going to do to our answer is give us a negative number, which tells us that it's in the down direction. Okay, so when you calculate all this out, you should get 70.3 meters. And that is the height of the golf ball.